So now, for the next 10 minutes, you are hired by Scandinavian Airlines, and you are hired to do some planning and some risk analysis and stuff, and they actually hire people like that to do stuff like that. Now they outsourced that part, but previously they hired, so now, but the company, they have outsourced it to still do stuff like that. Very simplified example of real life, of course, to make a point. Let's assume that we have people coming in on a flight. We are worried about the weight of passengers here. Overweight is expensive, and at some point overweight becomes dangerous, right? We forget about passengers, we forget about the pilot, we forget about food, not passengers, sorry. We forget about luggage, we forget about food, we forget about everything else, and we just talk about the passengers, right? So we are having a plane that can take 55 passengers. We're also being told that it's no good to have more than 4 tons, 4,000 kilos on the plane. That's our definition of overload. The question is, how often will that happen to us? And if it happens too often, should we change the definition of how many passengers we want to take on this particular type of plane? So that's your task as the engineer, the guy with the brain and the ability to use it in the company. You are to help the management to get hold of this. For instance, what is the probability? If that's our model of the world, how often will we end up in a situation where the plane will be overloaded, given my description of my assumption of how the world comes? This is a very standard thing to solve, also in the exercises I'm giving you, also at the exam. I would say that the first thing we should be worried about, probably most of us already was there, what is actually the total passenger weight? That's the thing, that's the random thing, which will change from time to time, right? From time to time when we fill up the plane, that's the individual events. Fill up the plane today, again tomorrow, the day after tomorrow, blah, 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 even maybe more times on a day. What is that y actually expressed by whatever I have put here? Can I put this into math such that I can start answering the question that I'm given? So that's my question to you now. You are the guys hired by SAS. You get a pretty good salary since you have your engineering degree with you. Now it's time to earn your money. What is y? And you cannot bring it home to do homework and come back tomorrow. I'm the manager, I invited you to my office now. I want to hear what you think now. Yes?
Y must be 55 times x.
I'm so happy to have you here. Do you agree? It's a little bit unfair to you, but you look like a guy that can cope. Otherwise, you look also like a guy that can do something about me afterwards. So anyway. Well, I prepared this. It's definitely not 55 times x. And I brought a slide where we're gonna make some computations doing what the consequences would be of you coming up with that very natural answer to the question. So that's also why that's typically what people would say. Let's talk about how I think it should, and then we can go back to thinking about what you suggest there. I was also cheating you a little bit. I was not being too precise in my sketch of the situation, but believe me, your manager at SAS Scandinavian Airlines will be just as little precise when he presents the real life to you. If I have been more exact and mathematically, I would have said here that I have x1 up to x55, all of them following this standard, this normal distribution independently. Because that's what is going on here, right? I have 55 persons coming independently of each other, at least I assume. Now the model does not take account of families, doesn't take account of a huge American Quaker family with 12 kids of plus 150 kilos or something like that. That's not part of the model, right? I assume it's randomly coming. Sorry to the Americans in here, sorry. Oh, I forgot. Whoa. Sometimes my mouth is faster than my brain, actually always. And sometimes I don't run into problems, other times I do. I apologize, I apologize, I apologize. Whoa. We have 55 people coming in, not one person cloned in 55 copies, right? So. The real first step is to realize that the relevant y, which is the total weight on the plane, is the sum of 55 contributions. And now, of course, you see why I talk about the rule I just gave you. We need this general rule of finding means and variances of such a linear combination. The mean is pretty obvious. I'm sure all of us would have answered that straight away. That, of course, the mean of 55 persons is, in fact, the sum of the 55 means, which then becomes this sum of the same thing, 70 plus 70 plus 70 plus 70, 55 times, of course, is just, in a way, 55 times the mean. So on the mean level, the thought that we do naturally is completely okay. On average, that's fine. So the expected value of 55 persons would be 3,850 kilos. Luckily, it's below 4,000, right, which was the limit. So at least we have less than 50% of the time that we have a problem, because I'm on the right side on the average. Now, it's the variance that will tell me how often am I on the right side or on the wrong side. I mean, what's the spread of this distribution here? Here we have to use my variance rule, and let me jump back to it. Although, I jumped the wrong way. Here it was. This variance rule that tells me that I should go on each individual one. In my case, it's the sum. So all the small a's are just ones in my expression. It's a simple version of it. Here we are. So the variance of y is just the sum of the 55 variances. Here I actually use this assumption of independence that I discussed before. It's used here, so it's not a trivial assumption. But that's as far as we can take it in our course here. Which means the variance was 100, so I add up the 100 variances. Sorry, I add up the 55 variances and I get a variance of 5,500. Variances can be a large number, that's just how it is. Let's find the proper probability. What is the probability of going above 4,000? 1 minus p norm. P norm is a left probability. 1 minus p norm is the right probability, right? To go above. I use the mean I just found. I use the standard deviation I just found, the root of the 5,500, right? So I find out that with 55 people on the plane, only in 2% of the cases where I fill my plane, I have an issue with overload. And then you can, of course, start to evaluate what's the price of the overload. Is it just a matter of paying a few people not to come on my plane? And then you might say, that's a fair, if I just pay this amount in 2% of the cases, it's still a pretty good deal. So that's the kind of things you can sort of trade off, and you can feed this into different kinds of economical modeling that you would use as a part of your running your business. Let's try this thing about what happens if I follow this path of solution. As I said, for the mean, it's not a difference, it's the same thing. But if I apply the variance rule, that would be the variance rule that was the simple one of the two that I showed you, that the variance of some fixed number times x is this number squared times the variance of x, and I get this number as the variance. This is a much higher number than the real variance. And how does that affect my computation? If I put in this variance, which is extremely wrong in a way, much, much larger than it really is, then I'm told, I can tell my boss, whoa, in 39% of cases, we have a problem with overload. We have to go down to 40 passengers or whatever I would find out by this. That would be pretty expensive for the company if you made that error, right? So it's important to get the variance right. That was what was going on today. That was the probability stuff. Next time we start the real stuff, the stats. Now we're ready for the interesting thing. So enjoy it out there. See you next week.